There's a live Q&A with this session that'll be hosted by Dale Dasker from the MySQL Sales Consulting team. If you have any additional questions, you can also email me or you can add them to the GitHub repository that comes with this presentation. As always, we'll begin with Oracle's Safe Harbor statement. I'll give everybody just a few seconds to read this before we continue on with the presentation. Okay, let's press on. So the program agenda comes in basically 4 parts. I'm going to go over the JSON and the JSON functions that have been added to MySQL 5.7 and talk about 5.7 a little bit in depth, as well as the X protocol, which also came in during the time period of 5.7 with the addition of the X plugin, and we'll talk about how to load that as well. I'll give a brief overview of Twitter, which I assume most of you are familiar with, as well as the developer API and how to stream from it, and then we'll go into the bulk of the session, which is the Python code of the GitHub repository. Now, you guys have the option of recreating this in a Vagrant virtual machine or just modifying your own host to run the code, or just using it as example code. It's just all up there with a number of different examples in both SQL and Python. So you can do whatever you want to. And then I'll do a little bit of data analysis on the generated Twitter, on the stuff that we capture. Depending upon the search term that you use, you'll probably have anywhere from hundreds to thousands of tweets per day captured, and you can find out some interesting stuff about it. So I'll talk about all that kind of stuff, and of course you can ask questions during the session in the live Q&A, or there will be some time at the end set aside specifically for being able to do additional Q&A. But let's get started. MySQL 5.7 has been a great release for us. It builds on some of the architectural changes that were made in 5.6 and allows us to do things like introduce a new data type, the new JSON data, and the functions that come in along with it to be able to aggregate JSON data and to be able to manipulate it and do searches and things like that. In addition, we also added the X protocol, which is a plugin for the server with its own release cycle that you can load that ships with 5.7 and allows you to be able to talk to the server in a whole new way over a different port with a new suite of connectors, as well as the MySQL shell that's available in JavaScript as well as Python and some other languages. I'm going to be going into exactly how to use the JSON functions, how to load the MySQL X protocol, and how to talk to it specifically over Python, not through the MySQL shell, which is a different application, but programmatically through Python scripts. And all those scripts are going to be available to you through the GitHub repository. The X protocol is asynchronous. It's collection friendly. The X stands for crossing over because it can do both SQL and aggregate collections of documents, principally through JSON, but also other types of documents. And it's very extensible, and it's got a whole bunch of different characteristics that we'll be looking at throughout this presentation. The X protocol is also HA aware. It lets you be aware of whether or not you're using group replication, what kind of failover is set up, and other things of that nature. That's for another presentation. So the other thing that we're going to be looking at is Twitter. If you don't already have one, you're going to need a Twitter developer account, and you can get there through the link at the bottom of the screen, as well as just it's pretty easy to find at the Twitter site, and just go to dev.twitter.com. But you'll need to get some access keys, so create an application through Twitter, get access keys and fill them in to be able to load them up inside your Python scripts to be able to connect. And then what you see here is the basic mechanism for how you connect to Twitter and stream back tweets. In essence, it's 1 or 2 lines of code in the examples that we provide, because we're going to be using a wrapper library. We're not going to be using the raw streaming API. We're going to be using a wrapper library called Twython. There's a number of them that are written in just about every language available, but Twython's very stable, and as I said, we're only really making one call to the streaming API as opposed to the REST API. So it's all going to be straightforward, and you're just going to open up a connection to Twitter, send through your credentials, and then start streaming tweets until you decide to Control-C your way out of the application. So let's get started with that. So let's go right into the anatomy of a tweet.
A tweet is a large JSON object, so if you're not familiar with JSON, this is an easy way to become familiar immediately. I'll start out by noting that if we look at how a tweet comes in, all JSON objects will have this underscore ID, the second field that you'll see here. That's a long field that makes globally unique. However, Twitter also creates their own Twitter IDs. And I will create an index, and I'll show you how that happens, a unique index to make sure that we've only got one copy of each tweet. Because if you do get a retweet, it will have a unique object ID, that underscore ID, but it will have the same Twitter identification. So you'll be able to distinguish them and only save unique tweets, which is an easy way of making sure that you preserve the proper favorite count and retweet count and status of any given tweet. Now then, if we look at it, you'll see that there's a whole bunch of different fields in this tweet, and this isn't even all of them. This is a tweet by another member of our team, Tony Darnell, who maintains the popular scripting MySQL blog. And in it you can see all of Tony's information is in the blue in the user object. This is an example of a nested object inside of a tweet, and you can do this in JSON. You can have arrays as well as nested objects, and you'll see examples of both throughout this tweet right here. But there is, so inside the blue item, you can see that there are a lot of different fields to the user object, and you can find out a lot about, how to look at his online images, his avatar, the links that his account is attached to, as well as his screen name and things of that nature. Then you can also get some interesting stuff, like obviously the text of the tweet, the language. This is the language that Twitter identifies the tweet as being done in, and that's not always the accurate language. It's done automatically. And a number of other things also in purple. I've highlighted this entities area, and entities is the URLs that are inside of the tweet, as well as the hashtags that are used. And I put that in bold. You can see that we have another array of JSON objects called hashtags, and each one of those has the text of the hashtag, which we'll be looking at later to try and find out, what are the popular hashtags, for example, in the stream that you get. And you'll see that each one of those hashtags, it's not just in what will become problematic for SQL. You have an array of objects inside of this tweet JSON, each one of which has the name of the hashtag as well as the indexes, which is the positions in the tweet, the character positions of where it appears inside of the tweet text. There's a number of other things. You can see the created at. If you take a look at this created at string, you'll see that while this is something that MySQL certainly can parse and will later, it is not such an obvious date representation that is done automatically. So we'll have to create our own date field around that. Which brings me to an important part about MySQL, which is that in the JSON implementation that is in MySQL, we do have types. It will automatically pick up, for example, things like what is text and what is numbers. So you will have numbers will have a valid numeric type, and you'll be able to do things like use numeric aggregation functions and things like that on numeric fields inside of this tweet automatically, and again, we'll be doing that later on. So this is just, again, take a last look at this. It's obviously going to be available for you afterwards, and you'll have quite a lot of these things to go through, but there's a lot of fields in here, and there's a lot of data in the Twitter stream. So there's a number of things that you're going to need to be able to run the example, and I go through them on the GitHub repository. There's a README file there that will tell you everything that you'll need, but I'll just run through it here quickly. Connector Python, the latest version, you'll have to download separately. It requires an Oracle login on the MySQL download site at dev.mysql.com. And I'm going to be using the development version of that, as I said. The current labs release is 2.2.1. And then that in turn is going to rely on Google's Protobuf 3. That's a library from Google that has the actual protocol, the wire protocol in it. and we are using a very recent version of that. I think they're up to 3.1 right now, but version 3, the one that will be downloaded automatically in Vagrant, and the one that is used inside of the connector is version 3.0, which came out this summer, I believe, in July or maybe even August. So then additionally, you'll also need a server running MySQL 5.7.12 or higher. That is the first production server that has both the X plugin included with it and also all the full suite of JSON functionality that I'm going to be depending on for some of the examples. This is the default for the recent versions of MySQL, as I note here, and this is also going to be a separate download and also something that is not going to be inside of the Vagrant virtual machine. We use Python 2.7 for all the code examples here, and actually the current version of the Python functionality in both the MySQL shell, when you enable Python as the programming mode rather than the default JavaScript, and also in the connectors is going to be Python 2.7. We are moving towards Python 3 like the rest of the world, but it is still especially in production database environments, I would say 2.7 is probably still the default version for Python. We also are going to depend upon several other libraries, principally the Twython library to manage the Twitter connection. And there's a number of different libraries. You could probably substitute in, as I said, there's only maybe 1 or 2 lines of code that actually use the Twython implementation. But I felt that it was an easy to use and stable one, and you can use the current production version through pip. And again, that'll happen automatically in the Vagrant tool. Vagrant itself is like Docker or a number of other things. It's a virtual machine technology. It actually sits on top of, in my case, on top of VirtualBox. It can use other underlying hypervisors as well. And it'll just make everything easier. There's a Vagrant file included in this GitHub repository that will let you just create a directory on your server, put in the connector Python that you've downloaded as well as the Vagrant file, start up the box, and then it just does all the downloading and building of the protobuf, and it installs the Python library, updates pip, and leaves you with a configuration environment where you're ready to go. All you actually need to do is put in the configuration strings, which, as I said, you need to have a Twitter account. You'll need to have a working MySQL server someplace other than on that machine, because I wanted to keep the size of that virtual machine down. It only requires about 512 meg of RAM, so you'll need to have a database server elsewhere. And again, as I mentioned, that database server is going to need to have the X plugin loaded, and you'll need to create a user on there and a database that I believe is called Twitter_MySQL that you have access to. Then it's just a matter of filling out the 2.cnf files with the proper credentials. I don't have your login credentials for your database, and you'll need to also add in the API key and secret for the Twitter apps account that you've created. Sounds like a lot, but I promise you it won't take you more than a couple of minutes. So here's a screenshot of the dev.mysql.com site. And as I said, when you go to download the Python connector, the 2 things to remember are that I want you to download the development version. That's the 2.2.1. You have to click on a tab. It's not the default choice. And then you're going to go with the machine independent, what I'm going to call the tarball, the tar.gz file. And once you've got it downloaded, put it in the same directory as your Vagrant file. It's all pretty straightforward once again, but I just wanted to include a screenshot for those of you who are unfamiliar with using the MySQL download page. So let's go through how to set up a Vagrant environment. And again, this is the easiest way. I think it's the path of least resistance to getting a full working client environment and being able to run the code easily, although you're free to use it however you want to. So you install Vagrant, and this is a link to it, but it should be fairly easy to find and install. You install Vagrant on your computer. It runs on Windows, runs on Mac, runs on Linux.
and then this should be the same computer where you've already installed MySQL 5.7, 12 or greater in another place, and it should be listed on the default ports if you don't want to have to change anything. And then you just create a directory. If you're not familiar with using Vagrant, you create an empty directory and drop in the Vagrant file and the connector Python that you downloaded in the last step, and then just watch it go. It'll probably take, on my machine, it takes like between 6 and 8 minutes to do everything that it needs to do, which is to provision the Linux box and get, in this case, I believe the current version is an Ubuntu box started, install Python, install pip, install wget so it can download and build Google Protobuf, and it'll download all the tools and libraries that it needs to do that, and then install, and then it'll just run through the connector Python tarball that you dropped on there, and it'll install that as well. At the end of which you will type in that same directory Vagrant SSH, and that will give you an SSH into your newly created virtual machine, and at that point you should be ready to go. The Python, if everything works as well in your machine as it does on mine, that's going to have you able to start streaming things. Well, again, as soon as you put in your Twitter and MySQL configuration in the 2.cnf files that are included there, you should be able to start streaming Twitter to your local MySQL machine. And here's that last bit to cross the finish line. You open up they're inside the repository, which I didn't mention. You will need to download the repository from GitHub. You can do that as a zip file if you don't want to actually use the Git command line tool. The advantage to using the command line tool is that as I incorporate comments and changes into the code that I've written over the course of the last week or so, it'll become more stable, and you'll be able to do git pull and get the latest version of that. But of course, you can also just download a zip file or whatever your favorite way of downloading things is, even the individual files or whatever. But inside there, you will find a file called Twitter_auth.cnf, and it will have places where it will be fairly obvious to put in the Twitter app keys and secrets that you will need to be able to connect to Twitter, and then the MySQL connection parameters, whatever the IP address is you need to get to the machine that is running MySQL, as well as the username and password. I don't have any default set, so you just create your own, and I do believe that I am assuming that the database is going to be called Twitter_MySQL. So you enter in both of those, you enter the right information into both of those files, and then you just pick a search parameter. I picked the name of our mascot dolphin, Sakila. You could do something like MySQL is what I kind of did in a lot of the examples, and that's the data that you'll be seeing later on, is that I just let the MySQL Twitter search stream for a number of days and get thousands and thousands of tweets into the database, and then I did my analysis on that. If you want to use the name of your company, the name of your favorite sports team, I would not recommend right now using the term election. I did that and was quickly throttled by Twitter for too many requests, because that actually will pull down a whole lot of information in October of 2016. But anyhow, you pick whatever your search parameter is going to be and run the Twitter_xproto script, and that will start streaming search results onto your screen, as you will see in the screenshot to come, and it will also create a collection, and we'll see how a collection maps to a table inside of MySQL when you're using this X protocol called your search term _tweets in the Twitter MySQL database. And this is the resulting output in the screen that you have, assuming that you like the green on black terminal. What it does here, you'll see the line of code that puts this out right after it does a successful insert. It will spit out the @ sign followed by the user screen name, and then a colon, and then the text of the tweet. As you can see, the MySQL world is the world. We get it's fun to watch tweets come by around the clock in all different languages. A lot of them, there's a fair amount of spam out there, but there's also a fair amount of interesting things that are going on. You can see some of it here, and you'll be able to see your own soon enough. And then if you want to terminate this, the program basically just catches a Control-C and it should do a graceful shutdown. If it winds up shutting down while it still has some tweets being read in memory, it will write those out to a field called tweets.txt, I believe, and at some later date I'll have it pick those things up at startup and enter them in. But right now it's an easy way to be able to look at more of those, that eye strain chart that I had a few slides ago of the anatomy of a tweet. You'll have a bunch of those in your local directory. So now that I've talked about how to get the example environment set up, let's just go into the code for a while and talk about what happens both in the Python code as well as under the hood in the MySQL database. The X protocol is stateless and asynchronous, and it is the normal way of connecting to it. And the X sessions are the normal way of connecting to MySQL. The fact that they're stateless and asynchronous lets you do some really great things in terms of, as I said before, being able to connect to different types of MySQL environments. If you're using the router, if you're using group replication, or if you have a failover scenario of various kinds set up, you can actually tell X how to be able to connect to those, and you can configure it in a wide number of ranges. Sorry. But the basics of creating a connection is that you create an X session, and then if you're not using SQL but you're just using our stateless protocol, then you do as you see in the code here to create a session, and you create a session with these are the same things that you're going to be putting into that CNF file, but you'll see what they look like here. And then to create a collection, you just give the create collection command, and that check existence is just a good way of basically, if you want to do create table if not exists, then that's great. If you want to do a create table and have it throw that error if the collection already exists, then you would use this check existence equals true. Let's see what's going on under the hood. So this is show create table. On the underlying collection from that last slide, I created a collection inside of my Python code, and then this is almost what you get back. I say almost because in this case, if you look inside the X protocol example script that I include with at GitHub, then you'll see that actually when it creates the table, it immediately also creates a unique index on that tweet ID. And I'll show you how it does that. There's basically a couple of different ways you can do that, either in Python or in SQL, and I'll show you both. But I create a second unique key and an index on that tweet ID because I want to make sure that I've only got unique tweets. Otherwise, as retweets come into the database, as forwarded tweets come into the database, you can wind up having a whole bunch of duplicates. So if you're going to do things like look at what's my most popular hashtag, you will find that you've got a whole bunch of duplicate versions of retweeted things with hashtags and things of that nature. And so you've got a bunch of bad data. So I add another unique index, and that's that tweet ID that you see there. But other than that, you'll see that I created the table with the exact same name as the collection, and then doc is always the name given to the JSON column, and then underscore ID is also, as I said before, all JSON objects have this underscore ID that makes them unique, and so that is always generated and always created with a unique key that, as you'll see, is also the primary key. And then it's NODB, that being our default storage engine, and then you'll also see that it is UTF-8 MB4 because Twitter has fully embraced Unicode, as we will be doing. That is going to be the default character set for the next version of MySQL, and we've been very Unicode friendly for a while now. So that's the basics of what a collection looks like as a table. But let's add some documents to the collection. As I said, a tweet is a document, and any JSON object can be a document for the purposes of the X protocol, and a collection is just a collection of documents. So this is straight out of the example code, and so you'll see that I read off of the stream. I created a queue for all the tweets that come in, and then I've got a couple of different threads that read off of that to be able to try and keep up and try and load the database in multiple threads to try and keep up with the Twitter stream, which can get pretty fast. And then, of course, Twitter will start to throttle you if you can't keep up you will get cut off by Twitter if you are starting to not read the stream as fast as they're giving it to you. So I created an extra thread to try and help that process along, and of course you can see the Python code in the examples that you can download. But so I create a tweet batch, and one of the things that I'll note is that the asynchronous nature of the X protocol means that when I'm doing things like adding a bunch of items, that add call is going to come back right away. It's not going to block while the database actually does the adding, and so you can send that add straight through and it'll come back immediately, and then you can asynchronously get the response code from the database that went through, but in the meantime you can be sending more objects through. So you can keep your session open and just send tweet 1, tweet 2, tweet 3, and then get the response that 1 was okay, 2 was okay, 3 was okay, without having to do any blocking. But anyhow, in this case, the multiple tweets that I'm sending through are that when these tweets come in, I'm going to look inside them to see if there is a retweeted status. Now, as I said when I showed earlier on the anatomy of the tweet, that tweets can actually have more fields than were in that already small font eye chart that I was presenting there. And one of the things is that when you retweet something, that that other tweet comes through as a fully embedded object inside the first one. So in JSON parlance, we would say that there is another document inside that document. And of course, the nesting only goes one level deep, fortunately. But that means that you can strip out a full other tweet out of your first tweet and then just put it into the database on its own. And in this case, because I have unique collection of tweet IDs, odds are, if I've been doing a search for a while, that I already saw the initial one, and now I want to re-add it to the database with its new status, which means that it probably has a higher retweeted count, it probably has a higher favorited count, those sorts of things. So I just go ahead and get rid of the old tweet that was in the database, so that I can just replace it with this newer version, because you're not going to lose anything. The newer version is always going to have the more updated data from Twitter, and Twitter only maintains one copy of each tweet, so you might as well use the latest one that you've got. So the other thing that I want to draw your attention to is that down here we use what's called method chaining, and it's basically kind of a more intuitive way of being able to string different commands together. So if you want to, in this case, bind a variable to that tweet ID, and you do that for reasons of security, so you're not just pulling something out and injecting it directly, you're not allowing for SQL injections, you're using bind parameters. So you can bind it and then execute it all in one call by means of these chained methods on the end of the object. And this is another key thing about the X protocol that is in a whole bunch of different languages. It's in the JavaScript version, it's in the .NET version, etc., is that you'll see these chain methods to be able to, and the method binding as a way of kind of uniting the X protocol no matter what language you're using it for. Now, one thing about JSON columns is that they don't support indexing. There isn't a native way to index a portion of your documents in a collection. However, one of the things that we also introduced in 5.7 was this idea of virtual columns, and the two go hand in hand, that in order to create an index, as you saw with the tweet ID, on a particular column inside of a document, you just create a virtual column for that type. And in this case, we're also going to use that to turn the created at column, which, as I said, MySQL doesn't immediately pick up as a date time, into a proper date time. And in this case, because I'm doing a few different things, I probably could have used Python to be able to do this, although the cast call would have been, might have required kicking it back out to SQL anyway, in order to basically do it in bulk, so I'm not iterating through documents to be able to create dates. In this case, I just decided to use an alter table statement, and this also shows you how I use SQL inside of the X protocol. The first thing to note here is that I'm getting a node session, not an X session. And that is necessary because I'm using SQL, because I'm using a stateful language, and I need to be able to actually block and make sure that I got everything back correctly. So then I build up my alter table statement, and in this case I am going to add the created at column, and you'll see that I use these, that I use this as keyword there, and then that is going to create a virtual column that is going to start, well, a generated column. In this case it will also be virtual for the date time, and that's going to happen on the entire collection at once. Obviously I'm not going to be iterating through anything. And then I execute the SQL with, again, you see the method chaining down there at the end, and then I'm going to close up the node session and move on. So let's look at some of the data that I've collected. And initially I can do this in SQL. So now that we've created that date time column, and I'm sorry there's a little bit of noise on this slide, but I can do a quick analysis and find out how many tweets per day there have been. And I conceivably could have done this with another, by using a call to that cast function that I use to create the index, but since the index is already there, I might as well use it. So I'm just referring to the created at and doing a select with a group by, and you'll see that just doing that and adding a desk column is going to tell me how many tweets per day I have. And in the case of the MySQL database, I'm collecting, like it says here, between 2,000 and 2,200 tweets per day. I've done some other searches where you wind up getting 3 to 4 times that many, and then of course there's other searches like that Sequila, people who actually look for our dolphin mascot, you can wind up getting in the single digits of tweets per day. And then similarly, the select screen name and count. Now this is another thing that I've added on here, so I can show you, this is a little bit out of order, but I'll show you the slide where I create the screen name index as well, and we'll do that in Python. But again, if you want to see the top screen names, you can easily do that by extracting screen name from the user object, and then another later task will be to actually export the user objects out into another table. And then when we do that, unfortunately, the number one things that send out MySQL tweets, as of just about every other popular Twitter subject, is spam bots of various kinds. And so you'll see a whole bunch of different things that are sending the same tweet through again and again, and it's something that you'll have to figure out how to control for on your own. But you know, it's just part of the way that Twitter works, I'm afraid. So then here's another way to index a document, and in this case we'll just index a document. If you know that you're going to be working through the Twitter API, then you don't actually need to create the, I'm sorry, not the Twitter API. If you know you're going to be interacting with your database through the Python API, then you actually don't need to create the virtual columns. You really are only concerned about the index, so it will, behind the scenes, create a virtual column for you. You don't actually have to give it a name or ever reference it explicitly. What you can do is just use a regular session. Now, again, to use SQL, we had to use a node session, which only connects to one database, and it's kind of restricting in terms of using the X protocol. And here you can use an X session, which is the fully functional X protocol native session. And you put in your authorization tokens and get the collection that you're looking for. And again, I'm afraid that this slide didn't come through correctly, but there's other examples of it. It's the same as the create collection code that you saw a few slides back. You just put in the collection name that you're looking for, and whether or not, and actually much like with create collection, there's a way to say, and let me know if it already exists, and just give me back a reference. You can also, with get collection, similarly, you can say get me a collection, oh, and if it doesn't exist, I want you to create it. But the default is to throw an error if it doesn't exist, as well it should be. So you get a collection, and then you, again, do this method chaining that you can see here, where you pass in the create index, and you're passing in the name of the index you want to create, whether or not it is going to be, the first thing is whether or not it needs to be a unique index, and then you're going to put in the fields, And then the final thing you'll see there, that last false, is whether or not the type, obviously, is going to be an integer. And then that last false is whether or not the field is required to be there for the index to be valid. So there's another way that, in the case of that, retweeted status, where you have, it's a field that is optional in Twitter. So if you want to have something like a retweeted status where it's not always going to be there, but you want to index it when it's there, then you can say false. Otherwise, I could have put in true with this one because the retweet count is always there. And then you're going to tell it that you always want that index to be present. And then that dot execute, obviously, is what executes the underlying alter table. And I left in that node session line. Anyhow, in this case, I'll go back and I'll note that despite what the code says, you would do this with an X session. So let's look at some JSON functions and some different things that you're going to find inside of the actual inside of your actual documents. In this case, we're going to do this with regular SQL, and I'm going to talk about the actual functions that were added into MySQL 5.7. I could also do these things. The syntax is a little bit friendlier inside of Python, and I'll show you that as well. But to be able to look through the hashtags and find out how popular the hashtag MySQL is in my collection of MySQL tweets, it's a little tricky because if you remember from the anatomy of a tweet slide, there's an object called entities inside of a tweet, and then inside of entities you have URLs and hashtags, and both of those are arrays, one of the other native JSON types of objects. So to be able to find out what hashtags are inside of a tweet, you're going to be looking inside of the entities object and then looking at the hashtags array, and then that hashtags array is going to be an array of objects, each one of which has a text that is going to be the actual hashtag itself, and then a set of indices, which is the start and stop periods in the tweet where that hashtag is found. The same is true for URLs, by the way. So as you can see here, I'm using a straight select count, and then to be able to pull out the fields inside of an array, I'm doing a JSON search. And so to kind of work backwards, that last thing there is the path, is the JSON path to where the hashtags are going to be found. So it's going to start searching in that hashtags path, and so it's going to pick up all those arrays. And then moving a couple back from there, that MySQL is the actual search term that I'm looking for. Before that, you either pass in all or one for whichever one if you wanted to just return the first instance, or if you want to tell it how many times it finds that, and I'm putting all. And then obviously doc is the field where the document is found inside of the collection table, as you remember from the create table before. So I'm just looking for a count of all the places where that search of MySQL inside of the array does not come back null, and I'll find out that it is the most popular hashtag that there is. Now then, the next thing that I'll look for is I'll show you the basics of how you pull a field out of a JSON document in SQL. And the actual function that you're using here is JSON_extract. However, we've given you some syntactic sugar that you can actually use this doc arrow and then give it the path. And it's the same as telling it to do a JSON extract from doc of that path. So I'm doing that twice. I'm getting the retweet count, which is again the integer of number of retweets you've gotten for a particular text, and then the text, and then my order by clause is, and with the limit 1 is just going to give you the single most popular retweeted status that somebody has put up there, and it's actually in the time that I was collecting these things, it wound up being a reference to the Who Killed MySQL comic, which if you do a Google on that, you'll get the comic strip, and it's a kind of a whodunit of who killed the MySQL process on a particular Linux box. But that's a little bit of JSON for you. So I'm just going to end again with that safe harbor statement if you didn't get a chance to look at it before. In this case, I think pretty much everything that I was talking about, well, on the server side, we were looking at all production code. The X plugin, as I said, is already GA and has been since the summer. And all those JSON functions that we were talking about came in with MySQL 5.7.8. So those also you're ready to use in your production systems right now. However, the Python code that I was talking about inside of the Python driver is still in beta, so you can't really use that for production just yet. The next version is going to have even more functionality in it. There's a lot of great stuff, and the developers have said that they're open and anxious for more comments on what else could be in there. So if you have more ideas about what you'd like to see in the Python or really any of the other drivers, although for these purposes I'm mostly in contact with the Python engineers, then you can certainly put them into the comments or email me or into the Q&A with Dale, and we'll get those along to the engineers. But there's a lot of great stuff coming, and there's a lot of great stuff in there now, and I've only been able to scratch the surface of it. So I hope that you are able to dive deep into the document store functionalities as well as the X protocol and the JSON SQL. But I will leave it to the Q&A right now, so I'll get out of the way.